Hello, I'm Junlan from Education Department of University of York. I'm a second-year PhD student. Today I'm going to introduce a methodological part of my PhD project about developing and validating an internet-based battery tests of aptitude in language learning, which I give it a name TOR. In this presentation, first I'd like to introduce very briefly about my PhD topic, which serves as the background of developing TOR. Then I will talk about the theoretic framework that TOR is built upon and the rationales of developing this bespoke instrument. I will introduce the design of TOR, specifically about each subtest. Then I will introduce the data analysis plan, but in a very brief way. The last part will be about the advantages, downsides, and solutions I summarized about using a web-based instrument to collect the behavioral data, which I guess might be more related to the audiences and the theme of this conference. My PhD topic is about learning abstract knowledge of grammatical structure in the novel language in the lab-based cross-situational learning context, a paradigm used to investigate learning vocabulary and grammar rule by simply exposed to the language input without any explicit instructions. I will specifically investigate the role of surprisal in learning, with questions about whether surprisal could lead to better item learning than better generalization of the knowledge. The target language is an artificial language, Yorvision, created by Bovalenta and Marston. The learning population is adult learners with the background of Chinese as their L1 and English as L2. In my PhD study, individual differences will be investigated as the moderating factors to explain learning outcomes. This is because IDs have been argued as playing important roles in shaping the process of learning a second or foreign language. Under the broad concepts of IDs, which are taken as cognitive individual variabilities, I specifically investigate foreign language aptitude, which is also termed as language learning aptitude, as the ID construct. The conceptualization of aptitude has been developed since 1950s, and today it is still an important construct of IDs that researchers focus when they investigate second or foreign language learning in the natural or instructional context. It refers to a set of cognitive and perceptual abilities that influence language learning process. It can also be understood as a specific capacity for learning foreign or second language more efficiently. The theoretic framework of foreign language aptitude has been developed for more than half a century. Here I'm not going to talk more into the history. What I adopted in my study is a dynamic perspective proposed by Li and Zhao that the role of aptitude in SLA should not be considered as being fixed. Other variables, such as learning stage, are necessary to be considered to mediate the effects of aptitude. Since aptitude is a componential construct, I focus on the components that may involve in the learning process based on Scahan's macro SLA aptitude model, a theoretic framework that divides aptitude constructs into components that may involve in the stages of L2 learning. Therefore, I proposed that in my study in the cross-situational learning context, there would be two stages of language input and central processing, which may involve these cognitive processes, and they may be inferred from the aptitude constructs of attentional control, working memory, phonetic coding ability, language analysis ability, and retrieval memory. These constructs form the framework that TOR is built upon. Then how am I going to measure aptitude based on this framework? Since MLAT developed by Carl and his colleague in 1959, there have been several instruments developed to measure aptitude, such as PLAB, LLAMA, HiLab. But the instrument to measure aptitude in my study is not a simple pick-up practice because of some theoretic and methodological considerations. For example, some batteries were based on different theoretical models, therefore did not include all components I need, such as the working memory capacity. Some were specifically designed for language learners with certain language level, such as HiLab. There are also methodological and practical concerns. For example, most batteries are not openly accessible to researchers and could be expensive to purchase through user permission. Plus, the concerns about reliability and the validity of the batteries were recently raised. All these batteries use either English or translated version in Spanish as the instructional languages. Some batteries used participants L2 as the language to be learned in the test, which may have confronting issues because it could be hard to tease apart aptitude as a latent variable from participants L2 knowledge. There is also the issue of modality that we need to consider in the design. Perhaps the most important practical issue to me is how to administrate the data collection during the COVID-19 pandemic. All these suggest that to develop a bespoke measurement for my project might be a solution. Now I will introduce this instrument. Tor has 4 subtests to gauge componential constructs based on the macro SLA aptitude model. The instructional language is participant L1 Chinese, and the language to be learned in the test was adapted from Lithuanian. This is to ensure that the language was local to this population. I am interested in examining the effect of modality. Therefore, some subtests were designed in both oral and written modalities, so there was within-subject experimental design to compare the effects. Taking a test once would cost about 45 to 55 minutes. The most important feature of Tor, it was an internet-based test developed in the Java environment. Now I will introduce each subtest design. Tor A is vocabulary learning for retrieval memory. In this subtest, participants had 2 minutes to click each picture to learn the corresponding vocabulary. In the testing phase, they were required to click the correct picture to match the given vocabulary. And Tor B is sound discrimination for phonetic coding ability. In the learning phase, participants would learn 3 similar sounds related to 3 meanings. In the testing phase, they were asked to discriminate these sounds embedded in phrases and short sentences by clicking the correct meaning picture among the 3 choices. Tor C is the test of working memory capacity, which includes 2 tasks: non-word repetition task for phonological short-term memory and complex span task for executive control in working memory. Both tasks were adapted from some widely used working memory tests in psychology. Tor D is a language analysis ability test. Participants had 5 minutes to explore 24 pictures to learn grammatical rules, which are singular and plural forms of noun, verb present and past tenses, and verb negation. In the test, they were asked to choose the correct answer to match the given picture. In 3 months, I've got valid data for both between subject and within subject designs. For within subject design, participants finished test and retest with a minimum of 30 days interval. The sample sizes were promising. Currently, I'm still working on the data analysis based on the schema proposed in Bokenda and Byland. Basically, it starts from the observed score in the subtests to draw inference about whether the subtest is made up of good quality items. It then moves to investigate whether the subtest is representative of all possible samples of universal items by using the Rush model to test the fitness. And as a battery for the construct of aptitude, whether the subtest associated in a way that is consistent with aptitude theory, the explanation inference is to give the answer based on subtests unidimensionality, correlation matrix, and principal component analysis. Once I complete the validation process, I may probably revise some items, then Tor will be used to gauge IDs for my main study. In the last part of this presentation, I'd like to talk about some advantages of developing a web-based instrument to collect data. The first clear advantage is that it allowed me to cope with logistic challenges during the pandemic by moving on with data collection. It has clear advantages in conducting experiments internationally involving geographically remote participants, and the subject pool could be large in the short time. It is possible to avoid organizational issues such as scheduling conflicts or maintaining social distance in the lab space. And most importantly, it could be developed into an open access instrument and help other researchers to avoid reinventing the wheel, a useful open science practice, and could have sustainability in terms of research impact. An obvious difference between web-based and face-to-face data collection is whether the researcher is present during the data collection process. Because of the researcher's absence in the web-based test, several issues, if not downsides, need to draw our attention. First, the technical support could be quite indirect. For example, internet connections, computer setup, etc. The solution could be to prepare a very detailed testing manual for participants and to provide online assistance if necessary. Second, researchers have less control of the testing environment and participants' behavior. There might be distractions in the environment, and there would be no invigilator present throughout the test to eradicate behavior not abide by the instructions. I would suggest carefully set up the outlier criteria for data cleaning. Last, like face-to-face data collection, we always have the challenges in the longitudinal design. My study has about 30% alteration rate due to a very long interval between test and retest. There are some tips, such as the way to give thank you token or to give some useful feedback to participants at the end. For example, I give them a scoring report and explanation of the test after they completed the experiment. Perhaps a practical suggestion is to have a more conservative expectation to the final sample size so that you might have to over-recruit at the beginning. That's all about my presentation. I'm looking forward to questions and discussion during the online session. Thank you.